14A, number 10. And it says use the substitution method to solve the equations here. So the problem is when we're looking at this one, it doesn't have a y equals and a y equals that we're used to. This one does have a y equals something. And what we could plug it in, right? Like this is y and y equals this. So we could plug it in right here for y, even though this y isn't by itself. So I'm going to take this x plus 3 and I'm going to put it in right here for where that y is. Now when I have this, so I have put in, instead of y, I've put in the x plus 3 that y is equal to. I have both equations that I'm using. I've combined both equations, so now I only have an x and I have no y left. When I have this minus 3 times all of this, I just have to remember to distribute. So I'm going to make it as a negative 3 when I multiply by the x and a negative 3 when I multiply by this positive 3. So this 2x stays the same. And then I have a negative 3 times x. So that's a negative 3x. And then I have a negative 3 times a positive 3, which will be a negative 9. And that's equal to negative 4. And then hopefully here you see how to solve it. We're going to combine these x's together, and I'm going to move this 9 to the other side at the same time. So here, negative 9 and positive 9 becomes 0. A negative 4 plus 9 is a positive 5. And then this 2x minus 3x is a negative x. And we're almost done, except that the x is negative. So I'm going to choose to multiply by a negative 1 on both sides of the equation. And that will be a negative 1 times a negative x is a positive x. And a negative 1 times a 5 is a negative 5. So now I have solved for x. And the last thing to do would be to go back and put it in this second equation. Though really you could use this one also. This one's just a little simpler because it's already y equals something. Y equals x plus 3. And I said that x was negative 5. So I'm going to put the negative 5 in plus 3, and you'll have y is equal to
negative 2.
Good. So do you see how that works even though they're not both y equals something?
Yeah, I see that.
I mean, honestly, you can rearrange either equation. If you wanted to rearrange this so that it was y equals something, you could rearrange it and then set them equal to each other. You could even rearrange the second one. You could move the 3 to the side with y, and you could have it be x equals something and plug it in for the x.
Okay. And then, let me see. For 13H.
Okay.
8 and 9.
Okay, I gotta read the whole thing because I don't have it done. So do you have 7? Do you have the 4 inequalities?
I wasn't 100% sure.
All right, give me just a second and I will probably cheat and use the answer key real quick. And then... Okay, so your inequalities would be A is greater than or equal to 2B. And then the big equation was the 200A plus 500B has to be less than or equal to 10,000. And then the other little ones is A has to be greater than or equal to 5, and B has to be greater than or equal to 2. So that's that last sentence, at least 5 of model A and at least 2 of model B must be in stock at all times.
Okay.
So that top one came from, there must be at least twice as many of model A as B. So twice B would be A. And then this one is that one model A costs the store $200 and model B costs the store $500. And they can't have more than $10,000 worth in the store. All right. So
Yeah.
then on your graph, let's see, A is going to be on this line and B is going to be on this one. So I'm going to graph these two easy ones first. B has to be greater than or equal to 2. So where this is maybe 5, 10, 15, we have something here down where B is 2. So we have to be above this line. I should have made my graphs in a different color. Let's do that. So B has to be more than 2. And then it's a little bit tricky because the graph scales aren't the same. So you have to be aware of that when you're graphing this complicated one.
Okay.
I say complicated, it's just a line, but it's a little bit different. A has to be greater than 5. So my ultra straight line here. So we know that we're going to be on, I don't want to shade because it'll be really hard to see on my computer, but I know you have to be above that horizontal line and I have to be to the right of that vertical line because I have to have more than those. And then my A greater than or equal to 2B. So if you want, the A is kind of like your X and your B is kind of like your Y. So on both of these, you might want to put it that way just to help you see it. So if you rearrange this one, whoops, that should have been on the B. If you rearrange this top one as to Y equals something or B equals something, you're going to divide by 2. So when you do that, you have A over 2, or here, I'll even write it, 1/2 A is greater than or equal to B, or my Y. So we know that there's no y-intercept. So we're going to start at the origin and then you're going to go up 1 and over 2. So if I go up 5, I'm going to go over 10. If I go up 5 more, I have to go over 10 more. So I'm just changing this fraction to an equivalent fraction to help me do them on the lines that I was given.
Okay.
And so on your graph, it's going to look like it's going straight in the middle. No, technically it's not because it's a slope of 1/2. And it almost crosses right here, but I don't think it's exactly right there. And then what side of the line are we going to be on for this one? You could choose like A equals 0, B equals 5. And that would be like this point right here. Just so I know if I'm going to be on the top left side or like the bottom right side. When I plug that in, I would have 0 is greater than 5. And since that's not true, then I know that I'm going to be on this side of the line. So I'm just shading a little bit in here. And then we have one more line to graph. because we need it to end somewhere. That's the money, the amount of money that we're going to have in the store has to end our graph somewhere. So to graph this one, I would also get B by itself, or B, because that's related to Y. So I'm going to move the 200A over. So I'll have 500B is less than or equal to 10,000 minus 200A. And then I'm going to divide by 500. So over here, that makes it nice and easy. This one's going to be a little bit harder. 10,000 divided by 500 is the same thing as 100 divided by 5. So I think that's 20. The answer key doesn't quite give me the answer, but I think that's right. 100 divided by 5. And then this one would be like 200 divided by 500. So that's really a 2/5 A. And it's a negative slope. So it's going to be going not uphill, but downhill, which is good because I think it needs to cut off the graph somewhere over here. Okay, so maybe I want to rearrange it so that I'm looking at it the way I'm used to. Okay, so this is like y equals mx plus b, except that it's a and b instead of y and x. But my slope is still that -2/5. And I might even want to make it -20/50. I mean, you could change it if you wanted 20/50, or that's equivalent to 10/25. Because these markings go by 5s over here and 10s over here. So I'm just trying to get it to something that will be a little bit easier for me to see. And then it crosses at 20. So it crosses right here. And then I know that I'm going to go down 10. So if this is 20, I'm going to go down 10 and I'm going to go across 50. So this point right here. Well, that's not quite matching up with the answer key. So hang on.
Okay.
You could also, using your X and Y intercept. So like when A is 0, what is B? When B is 0, what is A? And that will get you 2 points on the axis. Oh, because I only went down 10. Okay, that's why. It's just because I miscounted, not because I did anything wrong. Makes me feel better. All right, let me go back to if I was doing, oh, why is the eraser? I can't get my eraser off. Hang on. Okay. I said that the slope right here was -20/50, but then I only counted down 10, but I went over 50. So if I'm at 20 and I go down 20, I have to go +50. So that makes this my next point. So I changed it from 2/5 to 20/50. It's the same ratio, so it's the same slope, but I just did it in that whole number so that I could use my graph better. Because if I went down 2 from 20, I'd be at like 18. That'd be a little hard to do. Okay, so as long as you keep your ratio the same on the slope, you can do like an equivalent fraction.
Okay.
All right, so if I go down from this point, from my, essentially my y-intercept, but it's my b-intercept, at 20, if I go down 20 and out 50, then that's my next point. So then I can connect those. And then I'm pretty sure I'm going to be inside this triangle, because usually on these kind of graphs, you're wanting something contained. But just to double check, I'm going to put 0, 0 in, because that's on one side of the graph and I can test that point. So if I put, even in my very original equation up here, if I put 0 plus 0, is that less than 10,000? Yes, it is. So I would normally do my shading on the whole like bottom left side of the line. But since I know that I have to be within the shading that I already have, then I know that it's going to be right in here. And there is a little bit, it doesn't quite cross. There's a little bit of a straight line right here. But if you graph it with a ruler, you'll see how to shade in between those 4 lines. So the inventory in the store has to be within this triangle shape.
Okay. Okay.
So like one point would be like 10 of A and 10 of B. If they wanted 10 of A and 10 of B, is that within the triangle shape?
No.
No. So they know that they can't do that kind of inventory. But if they want 20 of A and 5 of B, that's within the shaded triangle. So they could order that much, or they could have that much in the store. So it's somewhat of a useful graph. It just takes a long time to get it all done.
Yeah. Okay. And then, so are we done with 13H for 8 and 9?
Yes, so 9 just says give one legitimate solution for the numbers of A and B. So anywhere in this triangle, you could pick a point. 30 and 5 would work, 20 and 5 would work, 25 and 5 would work, 25 and 10 would probably fit. So any point inside this graph or inside the triangle would work for number 9.
Okay. And I'm so happy because like whenever I get stuck on like certain ones, I put it at the back of my folder. It feels so organized. So for 13C, I just wanted to review with finding the intercept and computing. So for 6.
All right, let me flip back to 13C. Number 6.
Mm-hmm.
Okay. So our slope, I just think of rise over run, and then I think of rise as my change in y's. So y minus y, and then my run would be my change in x. For some reason, they just list the second point first because it's the difference, and generally the second point is like further over in the higher number, but it really doesn't matter as long as you line up your points. Okay, so one of our points is 5, 1, and one of them is -5, -5. So if I just say this is point 1 and this is my point 2, then this is my x1, y1, and this is my x2 and y2. So then I'm just plugging into my formula for slope. I'm going to start with the y2, so a -5, and I'm going to subtract the y1, which is 1. And then my x2 is -5, and I'm going to subtract my x1, which was a 5. Then I have -5 minus 1 is -6. -5 minus 5 is -10. They're both negative, so I need to make them both positive. I could just say that 2 negatives divided together make a positive. And then I may want to simplify this fraction. 6 over 10 is the same thing as 3/5.
Okay. Yeah. I got that one right. I just wanted to double check. And then for 17 and 18 on the back of 13C.
All right. His car has a 16-gallon tank. He left for a 4-day road trip. He left at 7:45 a.m. and arrived at 2:15 after driving 338 miles. What was his average speed? So how long did he drive from 7:45 to 2:15?
So would you just subtract 7:45 and 2:15?
Well, you have that noon in between. So I would tend to say like, I would almost just kind of count it in my head. From 7:45 to 8 a.m. is going to be 15 minutes. And then from 8 a.m. to 9 a.m., 10 a.m., 11, 12, 1, 2 p.m. is going to be 1, 2, 3, 4, 5, 6 hours. And then from 2 p.m. to 2:15 is another 15 minutes. So in between that 7:45 and 2:15, you have 6 full hours and 2 15 minutes. So then I would change the 2 15 minutes is a total of 30 minutes, and I would say 30 minutes is half an hour. So 6.5 hours is the total amount of time he drove.
Okay.
If you want to do it mathematically, you would need to stop at noon and go both directions. So like you would do 12 minus 7:45 and find out how many hours that is. And then from 12 to 2:15 and find out how many hours that is, and then add those two together.
Okay.
But personally, I just like count on my fingers when I have times within a day.
Yeah, I wasn't sure like how to do that. Like,
Right. Yeah, it's really complicated mathematically, but if you just like think through it and use your fingers, it's probably easier.
yeah.
And since I still do that as an adult math teacher, I'm going to say that that's a fine way of doing it.
Okay. Let me.
I didn't finish that problem, but that was the part you struggled with.
Yeah.
Okay.
And then 18.
Okay, when he left, he had a full tank of gas. So he had 16 gallons when he left. At the end of the day, it took 13 gallons to refill his tank. How many miles per gallon did he get? So really, that's kind of a tricky question. If he filled his tank with 13 gallons, then that's how much he used for his trip. So we didn't actually need to know that it was a 16-gallon tank. How many miles per gallon did he get? He drove 338 miles in 13 gallons. So we're trying to do miles per gallon. So you're just going to say that's 338 miles divided by 13 gallons. And I think it's about 26. And then I would say miles per gallon. Is that okay?
Yeah. Okay. Let me see. I think the next one would be 14H.
All right. Okay, just the beginning or one further down?
I think number 1. Yeah.
Okay, the wheelchair ramp requirements state that the slope must not exceed 1/12. So our slope has to be less than 1/12, I think. Would a 9-inch high ramp with a horizontal length of 8 feet meet the requirements? So I'm going to draw it like this. Here's my ramp. They want to know if 9 inches work for 8 feet. The first thing I notice is that I'm at inches on one and feet on the other, and I have to get them into the same. 9 inches is going to be a decimal, but 8 feet would be a whole lot of inches, so I'm not sure. Maybe you want to change 8 feet into inches, just so you're working in whole numbers. So 8 feet is the same thing as 96 inches. So now I'm just going to figure out what the slope is. It's rise over run. So I can say I'm going up 9 inches and I'm going over 96 inches. And then I would divide both of these by 3 and say that it's 3 over 32. And then I might just get that decimal because I need to compare that to 1/12. Is that less than 1/12 or is it more than 1/12? So 3 over 32 is 0.09375. And then 1/12 is equal to 0.08333. So this one is bigger. 1/12 is less than that. So I would say that this slope is too great because it's not less than 1/12. It's not a smaller decimal than that.
Okay. That makes sense.
You could have, instead of doing them into decimals, you could have converted this one to, I would have done it as 3 over 36. And then 3 32nds would be slightly bigger than 3 36ths.
Yeah.
Maybe you shouldn't cheat and use a calculator, just saying. So just looking ahead for number 2, it says what's the horizontal length of a 10-inch high ramp in order to meet the requirements. So you could say that it needs to be 1/12 and that the rise is 10 inches. So what does this need to be? So you're just finding an equivalent fraction. 1/12 needs to be 10 over something.
Would you multiply 10 by 12?
Correct. So 1 times 10 was 10. So 12 times 10 is 120 inches. And then you could change that into feet, but 120 inches works too.
Okay. I think that's it. Yeah, I think that's it.
All right.
Thank you for hosting the Zoom.